screen? Yeah.
Yep.
Okay. Yeah. So we'll just go through the step quickly again, as I mentioned, just cloning the repository. There's more than one way, but if you have, okay, I guess we can just continue with setting up the project. If there's any questions, please just feel free to ask or just paste it on the chat. We can address them as we go. But um, as a part of the process, will just be I've shared the Matterport workshop GitHub repository link in the chat. I'll share that again for any case it wasn't visible before. But so we will be just going through each of these steps to clone the repository and then setting up the Matterport SDK, going through setting up the project also. So step one was just making sure Visual Studio Code, Node.js, and Git is installed. If we have that set up, then we could move on to the next step. If any of you do not, please, now it would be a good time to just let me know. We can go through that step or paste it in the chat. We can go through that step. But I will just continue. We can come back to that. So the way I usually like to clone any GitHub repositories, I first navigate to the folder that I wish to clone that in, and then in that, I'm just gonna follow. Again, I'm following each of this step. So if you miss anyone along the way, you can always go back to the documentation and go through that. But the way I do it is I go to the folder, then I just type CMD, which opens an instance of the um, command prompt, and then I copy the URL. So the best way to do that is you just go to code, copy, git clone, and then paste that. So in that way, we have cloned the repository at that specific location. So it's pretty easy. And then the next step would just be to do git, sorry, cd, and then navigating to that location of the repository. So that would be step 2. So we're in the process of cloning the repository here. So we have done step 4. We have done step 5, which is navigating to the folder. And then the next step from there would be just to do code dot, which would open the instance of Visual Studio Code at that location. The next step would just be to setting up the SDK key. So for that, you would need to have a Matterport account set up. And there are issues with setting up the account on the laptop or just this web version. Devang, did you face those issues too? Was it not
No,
working?
I didn't
You didn't
face any
face?
issues. No.
Okay, but I've had issues where just the keys weren't working, or it's just the page was broken in some cases. So I just put the note in the email saying you could just set it up through your phone. But if you have that, then you should see something like this at your end, right? So I am in, or you might just see dashboard. So the step 1 is to go to settings and developer tools. And at the bottom, you will see add an SDK key. So I have mine set up, but what you can do is just click add SDK key, and that would open up a dialog. And then for the name, you can just type localhost, because that's what we'll be working off of anyway. So the name doesn't really matter at this point, but it would be helpful to you could just say a name. And again, this is all in the documentation. So developer settings, go down to SDK management, click plus, add the SDK button, and then use the name localhost. So the next step would then be, once you have this, is this showing up for you, Devang? Are you with me? Okay.
Yeah.
You can go to edit, and in the port you can type 5173, because that's the port we will be using as part of this project. In some cases, there have been issues with the port name or the number, I would say, but just to be safe, it helps to just add 5173, and then you would hit update in your case, right? So you want to keep that handy because we will be using that in the code. Okay, so let's quickly go through the project setup. over here. So the way I do it is the top you will see terminal, new terminal. And so with that, you would open an instance of the terminal in Visual Studio Code at that location. And then if you go to the top left, you have this folder directory. So if you open index.html file, and again, we'll go through the entire project setup. I just want to make sure the project is running at your end at this time. So if you go to index.html on line 26, you will see there's an application key, which is an empty string. So what we're going to do is we're going to paste that application key at that location, and then Control S or just save it. Once you have done that, we're just going to install all the dependencies and then get the project running. So I'm just going to go through these steps, step 4 specifically, and you can just copy paste from the GitHub repository. So it would be npm install at that location. And again, one issue we've had in the past is if there are any folder restrictions that are on the folder where you have cloned it, the npm install might fail sometimes. So just make sure there's no read or write restrictions on the folder location. So step 1 would be npm install. Which with that you would see node modules show up in your folder directory. Step 2 is to do npx Matterport assets static, and what that is we're getting all the Matterport assets. So that would be the second command to run. And with that, you wouldn't see any change in your terminal, but you'll notice that there's a static folder created in your folder directory. With me so far? Good?
Yeah.
Yeah? Okay.
Yeah.
And then the third step would just be to do typical npm run dev, which would start the instance of the project.
Yep.
And we are using white, so if you control click, it should open up the app. Should take a minute to load. Is this showing up?
Yeah.
And so then if you click on go to lobby, it should change your views. Can you do that check
Go to lobby. Okay. Yeah.
at the top? Yeah. Okay.
Yep.
Then you're good. One other thing to check is if you just want to go to the inspector and go to console. And if you just right click anywhere in space, can you check if the hover and like things are getting logged in the console, especially the X, Y, and Z coordinates?
So not sure XYZ, but some sort of like a UUID is being logged.
Okay, yeah. So UUID will work because if you go on to any sweep, which is the disks, the rings on the floor, a UUID will be. But if you do a right click mouse anywhere, can you see the location getting or the coordinates getting logged like you see in my screen?
Do this again. So inspector.
Are you using Edge or Chrome?
This is Chrome.
Okay.
So can you show me how did so I went to the inspector.
Mm-hmm.
Looking at console. Only left click is being interpreted in the console. Right click, nothing is happening for me.
The
So
left click will move you around, right? Like when you
yeah,
click on, yeah.
yeah.
But when you do a right mouse button click, it's not working.
No, it's not working. So let me do this. Do you know the shortcut to open up this inspector? Is it F12 or something? Because
Control Shift I or something like that, I think. Yeah, it's Control Shift C.
Control Shift C.
Yep, Control Shift C.
Nope, that right button does not do anything for me.
Hmm.
I can share my screen and show you what I'm doing.
Let's go through that. Yep.
Yeah, let's do that.
Do you have
Host,
permission to share?
no, host disabled participant screen sharing is what I get. So somebody will have to allow.
Participants, security. Okay. Yep. Can you try now?
Yeah, it's coming up. Screen. This is, hope you can see my screen now.
Yep.
So Control Shift C, going to console. So I'm,
Oh, you gotta just click once. Oh no, I think you're in like the inspector. So click escape.
yeah, I
Uh,
pressed escape.
you are in. I don't know why you're seeing that black circle. Joseph, that shows up when you're typically trying to go through each
Element, yeah.
element, right?
Yeah.
That is strange. Do you have
Do,
your
do you
Chrome?
want me to try some another browser?
Try Edge or yeah, try that. That might work. Yeah.
So let's go to inspect. I want to go to lobby. No, I have never used Edge here. So where is the console here? No, it's not
Um,
here. Elements. Yeah, console
console.
is here. This
There.
works.
This
See,
is working.
yeah,
Okay,
yeah,
great.
that
Yeah, I
works.
guess we can. Yeah, I think you might have some settings set up for your right-click handler on your Chrome,
Mm,
I guess, which is overriding this functionality. Okay.
no issues.
Is anyone else who's trying to follow along needs some time to get this set up?
So there was a chat from someone. I think Joseph. Mic isn't working.
Okay, I guess that was the issue in Chrome.
All right.
See if that was causing the trouble.
Uh, okay. So what's it saying? Unclick the laptop phone button. Interesting. Let me try to do that. Yeah, Joseph is right. Nice. Nice
Okay.
catch. Perfect.
Okay, great. So I'm just going to quickly demo on what we would be eventually doing, but like we're just going to be overlaying some information on top of an existing Matterport scan, as you can see. You can see my screen, right? Because I
Yeah.
think yeah. So one of them is, you can add tags, for example, which would embed some kind of image to it. You can then add a link to it. So you can click on that and it would open up the actual product specifications, for example, that you have. So this is one. The second is, as you saw, if I go to the inspector again, we can get the sweep IDs at the bottom, which I'll get into more detail later. But then that's step one, and then you have also the actual coordinates. And so if I go to the plan of this, you will see that if I click anywhere, you will get the coordinates because this is the three-dimensional coordinate spacing that Matterport has set up, and then the actual scan lives or resides within it. And it's also in 3 dimensions. So what I mean is if I go to a point here, it gives me my y as 7.13 on level. But if I go down, if I click here, it would give me a separate y coordinate. So the coordinates are set up in 3 dimension space. So that's one thing. Second is we can also set up external buttons which will interact with the scan that we have. So that we can also create a tour. So you just click start tour and it would create an automated tour of the entire space that you have. And you can set up camera angles, speed, any settings along those lines to it. So for example, if I move this to transition time being 1000 and hit enter, uh, the scan will immediately move faster because it's live looking at the scans. If I increase the wait time to be 6000, and this is in milliseconds. So if I'm at 6000, then you'll see that at that location, I'm waiting for 6 seconds before moving to the next point. So you're effectively using the browser environment to push data to Matterport and pull data from Matterport. One other thing is if I start the tour and I keep this, maybe you just keep it small, and if I hit start, it would start the tour. But then if you wish to pause the tour at some point because you want to see the space, you can click pause. And notice that it has paused on this instance of the tour, so you can move around specifically. If you're having a conversation with your client who wants to see the space, you can move around, have a conversation, and when you click Start Tour, it would start from that location and continue. So it's a good use case for explaining. And the next thing is you'll notice that at every point, we're changing the camera angle specifically to where you want to look, which is helpful because if you want your client to see a certain fire exit or certain hallway that you have specifically designed or any design intentional move, you can have the client look at that specifically. The other thing would be you can superimpose tags on it, which I just went over. So if I go to the plan view, we have added 3 tags. So one is this tag, but then if you click on it, and you can also dock it. So what that lets you do is it creates a window on the side, and then you can toggle through the tags you have. So if I click next, it goes to the new. You can embed a video in the tag. So if you have a room that you have designed which is inspired by something, you can add media as part of it. So that's the next one. And then we will be also using some Three.js to superimpose 3D objects. So this is a mesh line that's been superimposed, and what that does is, follow path to go to lobby. So you can superimpose these lines on top of your Matterport's scan, and it would allow you to enable someone to manually go through point A to point B. And these are relatively simple examples, but in Matterport, you can have actual 3D geometry, FBX, OBJs that are superimposed, and we'll go through some of those examples that are on the website uh, for that. So you can toggle between design options specifically if you want to. So here are examples where if I go to plan, you will notice that there's one red exit and then there's a blue. So you can have more than one path, showing what's the best way to go to the lobby. for example. But you can also have text on the floor, and not just on the floor, you can have it on the wall, you can have it anywhere. And this text is dynamically placed using Three.js. So if I click on go to fitness room, it would immediately jump me into the fitness room. So you can have targeted sweeping uh, in that fashion. So if I come back to the lobby, I could then click on go to cafe, and it would jump me to the cafe space. And then on the cafe, you can jump back to the lobby space. So it's about how do you get information from Matterport, push it to the browser, and then how do you get information from the browser environment and push it back to the Matterport SDK. And that's how the interplay of data happens for this to function. So there's one example that I found, which was done by another source, but you can basically use this concept and create some kind of a showcase project. So here's just an example which I found. And if I go to space, what something like this would look like is how would you create a more immersive experience of your space if you have Matterport, right? So you could go to continuous visitor and then you can say explore space. So in that, you will see that, there's like an introduction that can show up in your web browser. You can have some spots, which can be seen. And then you also have certain areas that you want your client to specifically look at. So you could click on one of them, and that would open up that particular spot uh, in the space. And then you have tags. So if you click on the tag, you would have some kind of an information show up. You can have interactivity saying, next spot, and it takes you to the next spot, and the information can change potentially. You can also have responsive behavior overlaid on Matterport, where you have, docking happen specifically on how you would want it, explanation of the locations. Best viewpoint is another one which clients typically like, is like if I'm in the space, like what's some of my best viewpoints that I have uh, in that space. Yeah, I think it got stuck for a sec. But yeah, this is a good example of how you can really create a UI around a simple Matterport scan that you have and start creating a level of storytelling within this. So a couple other things is we've had clients which are specifically asking to um, use Matterport to do training of the space. So if you have it like a healthcare facility where from day one, everyone using the medical staff just needs to know where all the different rooms are. Like you cannot do wayfinding on day ones. You can use the Matterport scan to then train your medical staff, for example, beforehand, before they start working in the space. So these are some of the use cases of it. Yeah, so just wanted to give you a high level of this, and then with that, we can just switch to Matterport spaces in like how is a scan captured, right? So I'm just going to go through some of these fundamentals of this, but maybe one quick thing is in terms of like just a agenda breakdown, we've finished project setup, Matterport SDK intro is what I'm going to do now, and then quickly go over the project setup, architecture framework. We'll have a short break, and then we'll go into actually developing or making changes in the code as the last part of the workshop. So how is a Matterport scan captured, right? So you have a Matterport Pro camera, which scans the space. At the moment, the latest one is the Pro 3, and it has a tolerance of 3/4 of an inch. So not the best for CDCAs at the moment, but really good for capturing like TI scopes or just doing a scan of your space for that. You have a device, any device really, that can be carried along with the camera, and as long as you have the Matterport app installed in that device, the raw scans will then sit in the device memory that you have. What's good in this step is that if you wish to change any of your raw scans, you can always go back, make a new scan and feed it back into it. So this is really good. So this is the part where having the raw data is really helpful, because Sometimes you want to go back and make another scan of the space, or sometimes the overlap of the two spaces isn't good enough for the fidelity that you need. And so the way Matterport is set up is that each disk that you see on the floor, each disk is a location of the camera, and it does a 360-degree capture. And then you move the camera to the next location, and you do another 360-degree capture, and then uh, both the captures are then stitched. And so in this, you will see each blue point would be a location of the camera where you would have the camera, and then you're doing the scans of the space. So you can always go back and change it. After that, you would then, if you're happy with your scan, you would then upload it to your Matterport account that you all set up at the moment, where you get it uploaded, and then once it's uploaded, you would have Matterport stitch it together to create this immersive experience that we just went through. So in that experience, you will notice that we are jumping from um, one scan to the next. So you would see if you closely look at a particular spot, you will see that it transitions to what it looked like in the next sweep. And that's why when we go through the fly through, also you will see things are moving as we go, because this isn't really a continuous scan. It's instances of how the space looked like in every scan, right? But what's deterrent is once you have that stitched together, you cannot really go back and change it, because Matterport has stitched all of your scans together to create that space. So the next step would be just to re-upload your entire scan again and ask Matterport to stitch that again. So that's really important from when you're working with clients. You just want to make sure the quality of the scan is good before you ask Matterport to stitch it. And then when it's stitched, you could have more than one scan that is stitched together. So for this example that we're looking at, each floor was one scan. Each floor had its own file, and then Matterport stitched each floor together. And that's what gave us this these floors that you see over here. So entrance lobby was its own scan, which you can see. Best to see it in 3D. So if I look at it in this way, you will see each scan is still autonomous to itself, right? So I can click on this level, I can click on the second scan, the third scan, and the fourth scan. So you have essentially 4 scans that are working together, but then you also have all, which gives you the entirety of it. One thing to note is that Matterport at the moment is not really strong at its outdoor scanning properties. Like Matterport specializes in indoor scans, so it's mainly used by real estate clients moving forward, but it does have the ability to do outdoor scans, as you see. And that is because the scan has a limit. So after a certain point, the scan basically breaks down. So that's why it also has a radius limit for the camera, right? So just quickly going over the anatomy of it. So you can dimension in your scan. So you can add dimensions to the scan. There's selecting pro levels. You can change the view mode. As we saw, you can change the camera mode. And then as I mentioned earlier, each disk is called a sweep. So the technical language, what they're using is it's a sweep because that's where the camera was placed, and a sweep of the space was created at that instance. Really. So I'll quickly demonstrate the dimensioning. So if I go back to a floor plan view and go to the 70th floor and then just go into a space, you could double click to go into the space and then just click on measurement mode, start measurement, and then it gives you a zoom in, but you could start and stop. Oops, that's stuck. Okay, you just close this. Yeah. So you could dimension between any points and it would give you the dimension. But again, you need to understand that this is bound to a 3/4 inch tolerance. So 8 feet 7 inches up to 3/4 of inch tolerance for this camera, which is really helpful also. Yeah.
So is there some sort of a snapping behavior happening here, or how is it picking the points?
Good question. It's not the best when it comes to snapping. It's I would say in some level it is also eyeballing it, but uh, you would, yeah, it's not great with that because it's really just three-dimension points in space. Like it does not really
Mm,
understand that here's a horizontal point, here's a vertical point. So as I mentioned, not the best when it comes to uh, CD phases, but for early design, or if you just want to get into what's my typical door entry? Like, is it 8 feet? Is it 7 feet? Is it 14 feet? Like that, that's really helpful to it. Yep. Okay.
yeah,
I was going to quickly go over API and SDK. Is that something we would like to go over now? Or if people have understanding of it, we could just essentially skip the differences between API and SDK. And because we will be using the Matterport SDK specifically. Any preference, or would you just like me to go over this quickly as just a refresher?
I'm fine either way. Like we can skip it if you
I would
want.
say just for the recording.
Oh
It'll
yeah,
be helpful. Okay,
Yeah,
sure.
just for the
Yeah,
yeah.
yeah, yeah.
recording.
Sure. So an API is a mechanism for communicating between applications. For example, you have Revit API, which is, or Rhino API for those who have used that in the past. So you have your Rhino instance, you have an API instance, and and then you're using an API to communicate between the two applications. So simply putting it, it's a set of rules or instructions that allow different software programs to talk to each other. Uh, and the purpose of it is for, it integrates software between one another, and it's lightweight, fast, and usually specialized. So it's about understanding the use cases of when you would be using an API. And as this diagram shows, like you would have an API that would connect all of these different programs together between one another. On the other side, an SDK is a set of tools for building the application. So it is an entire toolkit that contains everything that a developer needs uh, to build application for a specific platform or system. So as opposed to an API, which is just a link of communication between two programs, an SDK is an entire toolkit of one program that can be used in another program to then develop features on top of it. And so it contains a variety of development tools. It's more robust, usually includes a lot of utilities as part of it. Here's an example that I find really helpful when explaining the differences. It's like simply putting it, an API is like a restaurant menu. Uh, the menu tells you what you can order, like which is the services, but it doesn't explain how the food is cooked. So the behind the scenes, like how a Revit API is developed, that's something you wouldn't typically know, but it would give you enough information that you would be able to work with the Revit API to then help build tools on top of it. So you make a request, which is ordering the food, and then the restaurant, which is the system, responds to you what you have asked for. So you're making a call to the API in your programming code, which would then enable you to then create features on top of it. So if an API is a restaurant menu, the SDK is the entire restaurant. So you get the whole set of tools, the pots, the pans, the ingredients, everything as a part of it, which would then enable you to then work with it. But what's important to understand the nuance here is that it's still specific as to what pans, what pots, what ingredients you get based on which SDK you're using. So a Matterport SDK would give you certain tool sets, which would be different than another SDK that you're using, which would give you a different set of tool sets to work off of. And that's what's important when using or deciding what if you want to use API or SDK for this. So just quickly going over the Matterport API and SDK overview. So key uses, and then the showcase, we will be using the showcase SDK. And anything in bold is what we are doing in this workshop. So we will be extending the experiences that I showed previously. We would be integrating third party, which is have 3JS extended as a part of it. And then the Showcase SDK allows you to customize and enhance the experience around the 3D space and navigate a Matterport 3D space in the browser. So there's more than one examples to it, but so one is to listen to events exposing details of user navigation, such as scan location and camera rotation. So we are doing that where we're trying to understand what the rotation is, the scan is. Add additional content and overlays. So we are doing that. Add navigation, such as interactive minimap. So you could potentially have a mini map that is sitting on the bottom right or some corner of your space, which allows you to interact with that space more seamlessly as you're walking around that space. Controlling the camera. So we are controlling the Matterport camera as we do the fly-through. Collect information about tags, measurements. So we are collecting information about the location, the tags that we have, and using that. Ingesting custom HTML into tags. So we are changing or creating specific visual interpretation in the tag itself, how the tag looks, what's the color of the tag, where the tag is located. And then staging 3D models. So we haven't particularly staged 3D models, but we are staging 3JS objects onto the scan. I will not go in full detail about the API, but there are essentially three different types of APIs in one webhook. So there's the model API, this is the model room API, and then the account API. So each having its own purpose. So you could have the model API for modifying models. Model room is to go a step further and automates like the room measurements, classifications, and understanding the metadata that is associated with each model. And then there's the account API to get like billings and tracking users across your organization. So that's more from a logistics standpoint. And then there's a webhook that allows you to do real-time event notifications. If you have someone that is processing your Matterport scan, or if a scan is stitched, or if it triggers any activity to send you emails or notification, you can use a webhook to do that. And all of this is present in the documentation, which we will be going over soon. So here's just a few SDK examples. As I mentioned, first is this navigation control. So you could have specifically points on the map, and if you click on a yellow circle, it then opens up the view. So that's something you could do to it. Creating and editing tags. So this is something that we will be doing today, is how do you create a custom tag? How do you embed color, vector, label, media type as part of the tag? Virtual staging. So you could have OBJ or FBX objects that are uploaded with materials onto your space and change within them. Or you could just create a really crazy custom experience with material overlay as part of it. And so there are a few Matterport SDK like coordinate conventions that we need to understand, because as we work through the code, you would need to understand how the coordinate system works in a Matterport space, right? So Y is up, and X and Z are your horizontal plane in Matterport. That's really important to know, because your Z axis, if you change, you will not move upwards. At the same time, you'll notice that there's a particular orientation of any scan. And so negative Z is forward, positive Z is backwards. And then same way, X is to the right, negative X to the left. And this is something that is not documented specifically in the Matterport SDK, but as you're moving the axis rotations within the Matterport scan. So you have negative 45 to the right, negative 90 to the right, and positive to the left. And so just to quickly demonstrate this, so if I go to the plan, you will notice that if I change the orientation of this, and if I try to go to the plan again, it will always bring me back to this orientation. No matter how much or where I rotate myself to be in a plan view, if I go back to the default plan view, it will bring me back to that view. And so this orientation here is this orientation here. So when you're trying to understand which way is positive Z and negative Z, we need to understand that you are using this default view that Matterport has set up for you as part of the plan. Unfortunately, the exact understanding behind this is not mentioned in the reference documentation, like why or what goes behind Matterport to choose which is this orientation. It's just how when they stitch your scan, this is how they would have a default orientation of the scan, and you have to work with it moving forward. Yep. Right. So with that, we can switch back to the reference documentation quickly. So I'm just going to go through how this reference documentation is set up. So essentially, with the Matterport developers, there are embeds, there's a bundle, and then there's the web component beta version. And we are using the web component beta version to set this up, which I'll get to when we get to the code of it. But let's quickly go over the vocab that's important. So as I mentioned, a sweep or a panel is the disk. And that's important because in the reference documentation also, a sweep is their methods and their properties associated with the sweep. So you need to understand what the sweep is to then find reference documentation for that specifically. So the UUID is the unique ID of the sweep. So as we saw here, when I go to a certain ID, what gets logged down here is the unique ID of that sweep. So if I click on the next sweep, you will see a different ID getting logged. So each sweep has its own ID attached to it. Position, XYZ, and I just went over that and how that XYZ coordinate system works. The transition. So there's essentially three types of transition. There's fly through, fade, and then instant. So to understand each, when I click on this, if it's going from one to the next, this is a fly through because you have both seeing at the same time. Fade is when it goes to just a black and then fades out to be the next one. And instant is the one where when we click on lobby, it's just instantly opens the new one. There's no transition particularly involved to this. And then with the modes, there's the inside view, 360, dollhouse, floor plan, and transition. So that can be accessed through here. So we have the dollhouse view. Then there's the explore 3D space view, which is particularly inside each of these. Then there's the floor plan view specifically, which we went through in the floor plan view. And then there's the transition between the modes view what that is in some way an extension of the transition property over here. So conceptually speaking on how the SDK works, we have an instance of the SDK which has the 3D showcase, and this environment that we're in, that's the 3D showcase that we're talking about, which is the actual scan itself. So that's the 3D showcase which uses the Matterport SDK to run. And we have our own JavaScript web application that is sitting alongside it. So it's about getting data from the SDK to your web page, to your application, and then executing actions back to the SDK. And then as a user, you're sending inputs to both the web page or you're sending your inputs to the SDK. So to explain that simply, if I'm clicking on lobby, it's me as a user sending information to my web application. If I move in space, I'm sending information to the SDK. And then my SDK gives me the values, which is the third. And then as I click on go to lobby, the web application then drives the SDK down. So we've gone through each step on how this overall how that is. So these were just screenshots directly from the documentation, which gives you the coordinate system in each case over here. And not so much important for this workshop, but just there's our API to SDK conversions, and they have set it up in a way where you have to convert coordinate system between the API and the SDK. But they have not mentioned the rotation, so this would be an important diagram to look at when it comes to angle rotations specifically. Okay. So we can then go to some of the tutorials on this. So we have SDK tutorials, and what that goes into is creating tags. So we will be doing this, but Matterport allows you to create specific tags and set properties on each of the tag. Once you have a tag set up, you can then change some of the inputs dynamically after that. They also use an embed.ly to embedly to check if the source that you're embedding into this works. They have that over here where if you have to select that and you can paste that in the embedly or and then check check if the source that you're working with is visible, and if it's working in that, it means it would be visible on your Matterport scan as well. Not trying to get into too much detail of that specifically. One good thing that I have set up recently is pathfinding, which allows you to find the shortest path between 2 points. So if you have a few points set up in your Matterport scan, you can set up a pathfinding algorithm that is specific to Matterport, because Matterport understands the point edge boundaries, and so it will ensure that you are following the inside of the space and not just completely stepping out of the space and going to the other end, which is really helpful because you could then use this algorithm to find the shortest path between 2 points for particular use cases that you have. There's also customized pointer reticles. So if you go to a certain space, you can change how your pointer looks. Specifically, so as you can see here, the pointer changes as you go to a certain vertical point cloud or horizontal. So that's also possible for specific storytelling if you want. And then just a few examples. So the first one was just which one that I showed is having this navigation control. So if you could have just a floor plan, and then if I click on a sweep specifically would take me to that point. You could have some tags on it, as I said, but this could be an example of having an interactive map that allows you to do that. You can change the style. So instead of fly, you could go to fade. What that does, it fades it from one to the next, and then you could go to instant, which would just change it instantly from one to the next. So you can set this up specifically. Dollhouse mode, floor plan mode, and then inside. So this just quickly goes over the types of views that we have set up in Matterport. There's also the tags quiz, which is helpful, where you can have some kind of a quiz that is set up. So you're feeding information back and forth. So if I go to say what brand is the fridge, just go to Mattertag, it would open up that location, and then you can answer these questions. You know, how wide is the TV? You can go to that particular location and then answer questions. So this is something that is really helpful for doing like medical staff or client or any kind of training that you would like to do, where you would have certain questions that are posed to people, and they have to navigate through the space and answer questions, allowing you to effectively communicate the intent behind the space or certain moves that you have done in the space for that. You can also overlay questions, so you can go to nearby questions, you know, over here, which says, and it's a few meters away. It says 3.3 meters away. So there's more than one way how you could set up a quiz specifically in that. Matterport also uses physics in a way where if you go into a space, it changes color. So you could set up these spaces specifically in Matterport where it would trigger an activity or change the lighting of the space based on if the user's in the space. So if you step out of it, the lighting could change. So you could do some test fits that you want specifically in Matterport. And then there's also sweep control, so you can also set up a radius specifically to here. So you can go there, and then it's not just bound to the actual space that Matterport has given you, but you can actually set up your own meshes around the space. As I mentioned previously, there's a virtual staging. So you can go to a spot and select your entourage that you would like to place in the space, toggle through options, this is a really helpful tool for designers and having communication with your client on different design options that you would like them to have. So you could have a catalog of what each of this looks like and go through the space, because what is helpful is you can be a part of the space and have the client experience on how it's going to look specific to that page. There's also an HTML live stream, so you could have like a video that is embedded specifically. So you don't have to have a Matter tag that has the video that has it. You could have the tag directly embedded as an object in this. You could have like a live stream specifically happening in that. And the last, which I mentioned, was this custom experience. So you could start this, and you can get into the space specifically and create interactivity with it, which says find the bunnies in the space. It's like Where's Waldo moment, really. But there's more than one application to this. You can also scan, or you can do a webcam. So you could have, you can have your own device show up. So you could essentially be embedded in that space. You could have your live feed going into the space over here. I'm not going to do that today, but you could have your hardware connected directly into the Matterport scan to have this functionality work. Are there any questions? Is there anything specifically you would like me to go over? Because the next step for this would just be into getting into the project and going into how the project is set up.
So I guess one question I would have is it normal for clients to have these cameras, or do they rent it from some agency? How does that work?
Yeah, great question. So it's a little bit of both. So you would have architect companies specifically have a scan, and they could use have the camera, and then they could use the camera to scan the spaces for the client. We've had certain clients who've had their own cameras,
Mm-hmm.
and when it comes to cost, the big chunk of the cost is in the camera itself. Like the scan is pretty straightforward to take. Like you could have really anyone from your design team go out and make a scan. It's that simple. But you could have someone from the client do that. We've had contractors who are on the site who just do a scan, and this has been really helpful to do some CA work where you just scan the space and send it over, and we do virtual CA specifically, at least like a first pass of doing a virtual CA. Had it before instead of having the entire team fly down and do the CA work for you. So that's been helpful. You could also have Matterport team go out and do the scan. The advantage of that is they understand the fidelity, so they would give you a really high res, well-stitched scan. And what I mean by that is, if you take this space, for example, these scans are relatively far away. So if you have one scan here and the other one there, that's pretty that's like solid 20 feet, at least 20-25 feet away. And Matterport recommends 8 feet, 8 to 9 feet for the highest fidelity. So if you want someone to go and have scans done every 8 to 9 feet, then you could have a Matterport team go out there and do that for you. But if it's a smaller space, we've had anyone really who has the time to go in and do the scan. And
Okay.
so it's a conversation with the client on the monetary aspect of the scan and putting that in the budget beforehand and explaining them the value towards the end of it. Because I think a big part of this is especially architecture clients are still haven't completely gotten around the value of using Matterport scan. And it's up to creative people like us to and who can also develop can creating these use cases to show how if you have a raw Matterport scan, what could you do with it? So you could overlay a rendering on this. You could have three scans that are in different construction phases of your project. So you would have original space, you would have how it was after being demolished and how you did the interior renovation of the space and create some kind of a storytelling that helps connect all the three together. So it's not just about the renderings that you create, but the actual scan of the space that you have.
Mm-hmm.
Okay. Okay, so we'll just switch gears and I'll just go over the project high level setup on how we have and then get into the structure of the um, project also. So before that, let me explain this together. So we are using the web component beta. So if I go to the home of this, we're basically creating a Matterport we're creating a Matterport object, a component specifically in HTML that has M, which is the model ID. And so the way to get the model ID is that if you go back to any space, uh, you will see. So if I go to Matterport gallery, you will see there's the Matterport gallery, and then the Matterport gallery offers open scans for anyone to use. And we're specifically using the JLL commercial office, but it allows you, there's a bunch of scans that you can use for personal projects or just testing out experiments for it. And these projects range from interiors to luxury apartments to mock-ups of TV show sets to even outdoor spaces. They've had a few outdoor spaces also scanned. So if I open this specific JLL Chicago space, you will see that there is a unique ID that each space has over here. So this one has the YSCH, and then another space would have its own. So when it comes to accessing that space, in the Matterport viewer documentation, you are adding your model SID, and then you're adding your application key after that. And that's how we have set up the project specifically over here. So Matterport viewer, that's the model ID specific to it, and then there's the application key, which is the SDK key specific to each developer. So that creates an instance of the Matterport in your HTML specifically. The next is to then feed that or connect that to your JavaScript logic that you have set up. So in your project folder, you would see that in the source, there is index.js, which holds the entire logic of setting up the different functionality that we have over here. But the most important one that needs to be initialized is the Matterport viewer and SDK. So we're basically using the documentation that is found online is to querying the Matterport viewer, which we have done here. There's an instance of the MP SDK, which is our instance of the Matterport SDK. In their case, they've just used MP SDK, and we are getting the promise that is returned from the viewer. And then I'll get into the object handler in a bit, but what this does is you're getting the instance of your Matterport SDK, and you're binding that instance to the viewer, which has the space. So we're trying to create that connection between the space, the Matterport SDK, and then our app accessing that Matterport SDK, which then accesses the 3D space that we have. Any questions on that logic of how we're combining this? Okay. So the way the project is set up is that we have the index.js, which is the file that keeps all the logic. We have object handler, which is the root of 3D objects. So I'll get to that in a bit, but here's where we set up the root for the 3D objects. In the objects directory, there's the path component, which is creating the paths that we see on the floor. There's the text component, which creates the text that we see around the space. And then as under assets, we have a few JSON files that will enable us to do dynamically input different values. So we can change the fly through, we can change the paths, we can change the tag data, which is what data is feeding into each tag, and then we can change the text, which is the text that we have set up on the floor. The rest is just a pretty straightforward setup. So if I go back to tutorial, you will see we've been following these steps specifically as we do that, is to setting up the path and then just a typical project setup. So Matterport recommends the Webpack, but for easy translation and package management, we're using Vite instead. So instead of having the Webpack config.json, we're having the Vite config file instead. So these steps, which is adding the web component, getting all of this, is done as a part of the Vite setup. So Vite is set up in a way that it would go through these steps when you do the npm install and then the npx static. So that will create a static folder, and in that static folder, it has the SDK, the sandbox, the SDK client. All of this documentation that Matterport offers is part of the static folder which is created. Okay. So let's go through just the overall project stack and project setup, then we'll have a quick break. And then we can get into actually making changes in the code to see how things are getting affected across the different across the space that we have. So as I mentioned, project is set up using Vite, which is a modern build tool for web development designed to make building and running projects faster and more efficient. There's more than one options that you can use. There are other options to Vite, which can also be explored. The project uses Node.js as a server, and as a result of that, we had to get Node.js first installed so that Node could access, so we could have the server up and running in the project. The NPM, which is a Node package manager, allows us to download and install the different packages that are needed for this. So the Node access both server and package management for us. We're using plain JavaScript for this project, but you could also use TypeScript, or you could have a React, Vue, Angular, any of these frameworks that sit on top of JavaScript or TypeScript as you build your project. State management frameworks such as Redux and Vue, state management, any of that can be used on top of this, because we're basically building a web application ground up. So it's really, there's no restrictions on how you would do that. However, one thing to note is Matterport offers documentation in React specifically. So it's just helpful to use React with Matterport because they have documentation in React, but that doesn't limit us to use React specifically for setting up this project. We could use other frameworks as well. And then we're using HTML, CSS specifically to get the the bare bones, and then the styling setup. For this project, there's not much CSS that is used except for just making all the buttons in a straight line. That was effectively it. And then the last, which is using the Matterport SDK, which allows us to integrate the 3D space into the web browser. So just quickly on a very high level on how the project architecture works is that you have an instance of the server. You have an instance of the Matterport SDK that you're calling or you're getting the instance of it. The server feeds into the web application, which uses JavaScript and HTML, which then is working with SDK to pull information and push information back and forth. And then the server is powering both to run. And then all of this is contained within the Vite application. So this is just a really quick high level of how each of these are connected to one another. So files that you should care about is, as I mentioned, we have a few input JSON files that we would be working off of. There are a few browser inputs, which is starting the tour, transition time, going to the lobby. And then there's the index.js, which has these specific functions that we will be working towards. First one being init Matterport, which is instantiating the Matterport SDK. Second is the binding buttons, which allows us to bind the buttons to the app. Subscribe to sweep, which logs the active sweep. So as we went through each sweep, we had the UID getting logged. So the subscribe to sweep function does that. Add matter tags adds the matter tags. Click handler gives you the coordinate system. When we right-clicked in the space, it gave us the coordinate system. Adding the path adds the path, and then at the end we have the 3D text, which adds the text. So this is just a high level of how each function is doing different adding different functionality to the project. So here we have we need to go a little bit about the 3D object scene. So to showcase that, I'm just going to go through the scene namespace. So what that does, I'm basically working off of this, is what that does is in our file, we have, let me just, so in our file, we have an I object, a node, and then a component. And in terms of how each of them link together is that the I component is the object that defines the 3D object itself. So this is where you would set up all of the 3D object logic. So if I go back to the code over here, you will see that there is a pass component and then the text component. And this is where I'm setting up the actual logic behind the 3D object. For example, I'm using mesh basic material. I'm importing 3JS. I'm setting up the mesh rotation. I'm setting up the positioning and the geometry. So all the properties that we have for the 3D object itself are set up in the object I component. Then there's the node, which it aggregates the components together and then binds it to the object. So that's set up in object handler. So in object handler, we are creating a new instance called add object. In the add object, we're creating a node, and then that node starts. And then this add object is added to each component that we have. So the component is set up so that it has an instance of add object bound within it, because we're making that connection back to the application. So simply putting it, the object handler is a root that defines or captures the 3D objects that we have. And then the object handler has the node. The node then connects back. The node then connects back to the, or creating the instance of the object that you have in the space. So all of this documentation is you can find here on how you would set up a 3D object hierarchy specifically, so that you can work with the 3D objects and overlay 3D objects in the scene. But this is different from uploading a 3D object because in that case, we're not really using the web browser to create the instance of the 3D object. We're just uploading a 3D object to the space. This is used when you're creating a 3D object in the web environment, like using frameworks like Three.js to specifically create the object in the web environment. I'm going to pause for a minute because this is a little not the easiest concept to understand. If there are any questions, we can go over this setup. Okay. Again, as we go into the code, you might get this handle around this more, but so just like understanding this from a high level, simple method is how does all of this come together simply, right? So first is to get SDK instant and you're calling all the functions. So when we do init Matterport here, so in the index.js file at the bottom, we have all of these functions that are called. So I'm just going to go over how each of these come together, right? So first is you get the instance, and then you have second is you're binding the buttons. So we have these buttons that are set up in the web environment. So we're binding them together. So that's step 2. Step 3 is we're loading the JSON input specifically to the bind buttons and the matter tags, because the matter tag information on where and how the matter tag will be placed comes from a JSON input. Because that's the next step in this. The fourth is you're creating the 3D object and independent 3D objects that are bound within it. So we're creating the object root, which is the object handler, having add path and add text, and then we're creating the specifics of what the path component will be, which will be added to the add path, and what the text component will be, which will be added to the add text, right? And then with this being set up in a more generic format, we can then use the paths.data JSON and then the text data JSON to then specifically feed where we want to add the path and where we want to add the text. So then this is just an overall framework on how each of these components and functions are working together, and how each of these inputs are bound to which of these functions that we're calling specifically to that. Okay. So now I think is a good time to take a quick break. And we'll come back and just start working through the code and making changes and see how, and I can explain how each part of the code is set up with the reference documentation on the side. Just one thing I would like to show is the Matterport reference documentation, which is, I can just share this link in the chat. So if you want to follow along to the side. Yeah. Oh, let's see. So we have each of these set up specifically. So if you can see here, there is a scene, there's a room, there's a sweep. So if I go to sweep, then we can get into how we can add move to or methods, creating graphs specifically to it, the different properties of which we'll be going through after the break. But there is a level of documentation to it. And one thing to note is Matterport is constantly changing this documentation. So in a few months, you would notice that some methods have slightly changed, some naming conventions have slightly changed. So it's about understanding that this documentation is evolving as Matterport is working on their building their SDK documentation. Okay.
Shall we set the time?
Sure. We can have like a
Not
5-10, yeah, 10-minute break.
45?
Yeah, 45. Yeah.
Sure.
Okay. Great. I'll just stop share for now. Yeah. Okay. See you all in a bit. Yeah. Okay. Are we ready to do some coding? I have shared the presentation PDF in the Slack channel. Can I share that also in the chat? Let me try. Yes. Okay, that would just help with as a as like a resource on the side to understand how the project is set up, and especially the Matterport coordinate system and rule of thumbs that need to be taken care of as we work through this. Okay, Devang, are you good to go?
Yeah,
With
yeah, I'm here.
coding? Okay. Okay, I'll share screen again. Okay. And just give me some feedback as we work through this, because since I cannot see any videos, it would be difficult for me to just gauge on,
Yeah.
if it's understanding, not any of that, right? So let's just go through each of these features one at a time, and then I'll go through the code, and then we can make some changes and then see how that's working specifically. Right. So the easiest one so far to set forth is from a data input standpoint is the fly through working. So I'll go through the code on how the logic is set up. Then I'll go through how the JSON file is set up to enable each of the functionality, and then we can work through just making a few changes on that and seeing how it affects the experience.
Mhm.
Okay. But before that, maybe I'll just quickly go over how this index.js file is just set up. So at the top, typical setup, we have a few imports that we are importing each of the JSON files, and then we're setting up a sweep transition time default of 4,000 and 2,000. So when I reload, you will see that it 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 could default to that. But then we're also setting up few variables here. Line 31, we're setting up the getting the instance of the Matterport SDK and then the instance of the object handler. I went over this previously, but which is we're binding the viewer to the app, and then we're binding the SDK to the app. So we're creating the pipeline between the Matterport SDK, the viewer we have on the app, and then the JavaScript logic that we have natively. Similarly, we're creating a new instance of the object handler, which takes the SDK as an argument within the object handler, which we have set up over here. And so then to get into the functionality of specifically to JavaScript setup that we have, we're binding the buttons. So we're querying the buttons from the HTML, and then we're binding them to a click handler specifically in here so that we can start and stop the tour specifically to that. And then going back to the index.html, it's a relatively straightforward setup. We have in the body, we have just a menu on the top, which has the start tour, transition time, 2 buttons. And then we have the instance of the Matterport viewer that is contained within this over here. And then that's really it. And then we're capturing the buttons and then the text fields logic back into the index.js file. We're also setting up the event listeners to get the inputs. So we have a certain amount of wait time, transition time, which is these text field inputs that we're having over here and how that is affecting the sweep transition time. And then we're subscribing to each sweep so that we can log the sweep ID. We'll be going through this each in detail. I'm just going to go through this quickly first just to see how the code is organized. We're adding matter tags, which is a direct function that is offered from Matterport reference documentation. And then the right-click mouse handler is set up specifically to get the coordinate system. And then adding the mesh path line, we're adding the object. So we're adding the text to the scene and then setting up the move to space function. And then we're adding text to this scene. And then the last step, we're just creating that fly through to navigate through the space over here. So, and then as I went over this previously, we're creating the entry point into the application and then calling all of these functions to execute. So with that, to set up the tour, there's a few things that we are doing. The first one is specifically binding the buttons here. So we're binding the buttons to the app, which allows us to start the tour. And then I will switch to the SDK in a bit. But to enable the tour, we first need to get the coordinates or the UIDs of where we want the tour to be, right? So I'm going to this one first, and then I'm going to the next sweep, which is this one over here specifically. And so that is done by the subscribe to sweep function. So if I open, yeah, go ahead.
So when you click somewhere, is it trying to find the nearest sweep and then it just moves there?
Yes, yes. That's how
Right.
so that's native to how the Matterport is set up. So even if I click here, and so the way the Matterport SDK is set up is that if you click between 2 sweeps specifically, it will always move to the next one.
Okay. Nice.
So what that means is if I am between these two, but if I still click closer to this end, it will still move to the immediate next one that is on the screen. And it is also bound by what you see on the screen.
Yeah, okay.
Yeah. So let me open the reference documentation. So in this, we have MP SDK, which is we're at Matterport SDK. So that's our entry point. And then within that, we're going to go to sweep. So with that, we're accessing the sweep namespace. And then current dot, so we have a few properties of the sweep, which is the one that we want is what sweep I am on at the moment, right? So that's the current sweep that I'm on. And then we're going to subscribe to it. And so we use a subscribe function that then gives us the sweep that we're at specifically. So current sweep.id, and so it give us the ID. And one thing you'll notice is that this is I added this intentionally, which is when I had set up the code previously, the documentation said ID, and then in the last few days they've changed it to SID. So you'll notice that ID also works, but they're constantly changing the documentation. So in the future, we could also use SID specifically. And so in terms of what it gives us an empty string when we are in transition mode, but then it gives us the current SID, which we are logging here, give us the current sweep.id, or in this case, just SID. And that's the one that we log in the console. To demonstrate that again, when this function runs, as I go to it, it's logging the current ID that I have in the space. So the next step to that is setting up the transition time specifically. So we're creating another function that says bind text inputs, because these are text inputs that we have specifically. And then we're first querying the input time and the wait time. We're adding just error handling if there isn't any of these present, which we can say cannot find inputs. And then in the transition time input, we're adding an input listener, which says, give me the value of the target that I have. Give me the value that's placed in that text box. And then we have a sweep wait time, which and then we're defining a sweep transition time, which are two variables that are defined at the beginning over here. By default, we're just using 4,000. So if I remove any of this over here, it would default to 4,000, 2,000 as my default value while working with it. But then once we have that, we are using that value to set up the transition time for this. Right. Then we're also setting up a Boolean value, which is tour in progress, false. So at the beginning, we don't want any tour to start by default when you open the space. But then when we bind the buttons to it, we say on click. So when we have a click function attached to the button, we're saying on click, the tour, we're starting the tour. And then on click again. So if I start the tour, we're saying on click again, pause the tour, which we have paused. And then on clicking the tour again, we would start the tour. So we're creating this Boolean interface based off of this button that we have. So you'll notice that there was no values here to start with, but then we defaulted to the 4,000 and 2,000 values that we have set up at the beginning.
Mm-hmm.
Right? And then when it comes to the sweep logic, here. So we're starting, I'm just going to go over how the sweep logic is set up. So for that, by default, we're using, again, the MP SDK. So if I go back to the namespace, I'm going to be in MP SDK and then the sweep, within the sweep. And then within the sweep, we're using a method called move to. So when you go to move to, it says move to a sweep. So we go to move to sweep, But then within move to sweep, we have a few options on how we want to move to the sweep. So I will go to move to options. In that, are we rotating? Are we doing a transition from one sweep to the next? Or are we setting up the transition time? So for that, we are doing a sweep.transition. When I click on sweep.transition, it gives me, so now I'm 3 levels deep in the reference documentation. It gives me a few ways of how I want to move from one to the next. And then it gives me explanation for each. So we're saying transition.fade. So are we fading from one or fly? So if we do fade, it's going to just fade in and out, in and out, in and out. And as opposed to if we do fly, then we can just fly from one sweep to the next. So we will be using flies to create that smooth transition from one sweep to the next. But you could use the other two if you want. And then within that, in the fly, we would specify that specifically. We're also specifying the transition time, which we have set up at the beginning. And then to ensure that we are stopping before the tour ends, we're going to get the length of the fly-through path that we have setting up. And we're making sure that we're less than, not equal to, but less than the length of the path to make sure that at the last sweep, it's not looking for the next sweep to get to. So one thing that we could test is quickly to change this from fly to instant. So if I want to go to maybe even fade out, we will see that the style changes to fade out mode from there. So every time you make a change, it is a hot reload. So White allows you to do a hot reload of the app. So you will see that it instantly loads. And then if I do start tour, it's going to go through one. It's going to wait for a minute and then go to the next. But again, so this change is based on how long it's going to take to transition from one to the next. So not the most ideal, but you might have a few use cases where you would be using this. You can pause it, but we're just going to go back to fly for that. And again, when I save the file, it does a hot reload of the space. And so the file that's getting that from where we're getting this information is the fly-through path.json file. And the inputs that we provide to it are one, the sweep ID, which is what sweep ID that I want to be at first, and what's the next sweep ID that I want to transition to, and then what's the angle that I'm working with. So to explain how this angle is set up, we should use the this documentation. So I'm just going to keep this as reference over here. I don't know, it's the best way to. Okay, I'm going to try this. So we're going to keep this as a reference, and then we're going to see how each of these sweeps works with the angle that we have set up. So what that means is, if I am on my first sweep, so if I go to start sweep, it brings me to my first sweep, right? I'm going to pause here. So the sweep ID is 0994C, which you see here 0994C. And then if I go to plan, it shows me where I am. So that's really helpful. And then if I compare this to my Cartesian plane setup that I have here, it tells me that I'm looking at 0 degrees when it comes to angle, because I'm just looking straight where I want to be, right? So that would be step one. And then if I do start tour, it will go from one to the next here. So now at this one, I'm pausing again. I'm getting the sweep ID for that, which is the 41C1. But then I'm looking at an angle specifically and not dead on straight. And I can use this Cartesian saying -45. So I'm specifying -45 here, which allows my camera to specifically look in that axis. Because when I look at it in plan, if I'm in this here, and if I put this to the side of it as a reference, I'm looking at negative 45 degrees to that angle that I'm looking at.
Nice.
And again, you could have someone look at a 3D angle. So you could have someone tilt their view, not just here, but maybe up here as well. So in that case, then we would be changing the other axes dimensions. So right now, if I want to make this big for a sec. So I am moving around the y-axis, but if I want to move along the z-axis so that I'm changing my view in that direction or in the x direction, I could specify those values as well. To have someone specifically look at a beam that you want to show your client. You know. So we're using that same logic for each sweep as I move forward. So in this third sweep, it gives me the D2A0, but right now it's negative 90 because now I am looking at hard right on my Matterport space. So I'm looking hard right clockwise. So now clockwise is negative 90. So what we could do is we could change some of these. So we can create a new fly through so I'm going to try and create a new fly through that takes me from the lobby in the opposite direction to the fitness center here, right? So what I'm going to do is I can just edit this file that allows me to move backwards. So we can start from the same sweep, which is this one. This is my initial one. But now instead of looking forward, I need to do a complete circle. So I'm going to do Y180, right? So I have that. Then I can I don't need to go to this one because it's in the same line. I'll go to the next one, which is the 232. So I can copy that and just paste it as the next sweep ID. But then maybe I want someone to see this specifically, saying like, here's my signage that I want you to see. Because we could have graphic design studios that want to showcase some of their design intents. So I'm just going to keep this angle to be 180 so that at that sweep, I'm still looking down. Then the next would be this sweep. Just going to copy that. But now I'm looking left. So if I go to plan view, I'm looking dead. I'm on this red sweep. I'm looking dead left. So if I use this Cartesian plane, it needs to be 90. So I'm going to just go and place 90. And so then we can check that. And then I'm just going to delete the rest just so that we can have only 3 sweeps set up at the moment. When you do a hot reload, you don't even have to click go to lobby. I can just say start tour and it's going to fly me to that location. This is my first one. This is my second, so I'm looking at that signage. And then this is my third one, which then pushes me into that third sweep. So we have logged 3 sweeps and we have created a new walkthrough, which is automated.
Yes.
Am I going fast? Would you like me to? Let me know if you're able to just create your own, or I can go a little slower if you need. Okay. So in that case, I'll just finish up with this. So I'm just going to go to the last one, which could be, and again, this is up to us to choose, like which one do we want? Like, do we want this sweep that shows me the reception and the fitness, or do we want maybe this sweep that shows me the seating, everything? I mean, that's up to us how we want to decide. I'm just going to use this one specifically. So now 7.5, but for that, I will copy this over. I will copy this over and then 7.5 this, paste that, and just do a quick check again. So go to plan view. I'm over here and I'm looking in this direction. So if I go back, that's going to be 135 degrees is kind of 135 degrees is what I want to look at. So 135, save. And start tour. There. So it brings us to exactly where we want to be. And you'll notice one thing is that the cameras are set up in a way that if you're at that sweep with dynamically placing this, the angle of the camera is exact to just that sweep. So what that entails is as opposed to manually moving through this. So if I'm in this view, which is a little tilted view, if I go to that, it keeps me in that view, as opposed to if I'm placing the angle degree manually through this, it's going to, sorry, it's, if I go back to that, it's going to alter the view so that it's in, like verticals remain vertical specifically to this. It's not going to point me down or up or any ways, because it's the exact angle value that we want in that 3D sweep. Is it working at your end, Devang?
Yeah, it is.
Great. Nice. So when it comes to setting up the fly-throughs, I mean, something that we could have as an additional functionality is if you start the tour and then if you pause it, uh, you could have a reset. Like right now, if I pause this, if I move around and if I do start again, it brings me back to this, but I could have a reset where I'm just starting all over again. So there's other functionalities that you could add specifically to this once we have it. So just so that we understand this from a conceptual lens, what we have done is we have used the SDK to get the sweep ID information out. We have then used the camera angle data to push that back into the SDK. But then we've also used the web application button and transition features to push back to the SDK, which then affects the 3D showcase. So it's a constant back and forth of data between your web application and the SDK 3D showcase that you have set up through the SDK instance that you have that's connects the two. Yeah. Okay. So next we can move to the adding the matter tag, which is also a really good use case example. So here, so I have to say, follow path to lobby. And then what's good about matter tags is that it allows you to quickly jump between spaces too. So I could just click on this, I go here. If I want to go to the blue, which is the other end of the space, I can click on that and go here. So it's a good way to jump across spaces really quickly. Right. So the logic to set up the matter tag is pretty straightforward. And the reference documentation for that can be found in, if we go to tutorials and then creating tags. So if I go here, it just gives you the breakdown of how the tag data input is. And so we're using this in the tag.data.json. So we're having label, we have anchor position, we have stem vector. And so it also tells you what each is. So anchor position is where the tag is placed. Stem is the actual stem. In some cases, you may not want a stem. So you could have the stem to just be 0, 0, 0. The disk itself, and then the color associated with the disk. So we have red, green, and blue, adding a description. So we have all of that fed as a JSON file to this. And then adding the matter tag is actually pretty well documented on how to do that. So we're essentially using that same documentation that is found online to add the matter tag. But we're just using a for each loop so that we can use the JSON input for that. But essentially what it's saying is you can use MP SDK tag add, and that's because we have a tag functionality here. So we are using the SDK matter tag add, and then the matter tag information that lives within that tag. So if I go back to the scene, so MP SDK, in that I will go down to tag. In that tag, we have a few functions here. There's attachments, there's data, but then the method that I want to use is add, because we're adding a tag. And then that gives us documentation on how do we add that tag. But then you'll also notice there's an edit billboard. And what that does is, so the way the Matterport SDK is set up is that you first need to add a tag and then edit the contents of the tag. So you first create the instance of the tag and then you edit the contents of the tag. So that is seen, it's documented here also, called editing tags. So if you go to edit tag, it tells you edit billboard Matterport SID. So we need to provide the ID of the tag to know which tag to change. And then you change whatever you want to change within it. So in this case, we're adding, yeah.
So there is no way to initialize that instance of that meta tag with the information that we want, or we have to just create it first and then edit it.
So if we want to customize the tag, then we need to do the edit billboard. If you just do add a tag, it will just create the tag with no information in it.
Okay.
Yeah. So just a plain tag and then the default tag from Matterport is I think white color. So it would just create a tag, which is the default tag. This is white with red around it. So it would just create this by default. But if you want to make customization on top of it, then we need to have a callback that says make a customization on top of it. Yeah. So this is pretty well documented. So if I go here, then I can also go to so yeah, there's the add method, but then there's the edit billboard method. And then the edit billboard method allows you to change this specifically. So the way we're doing it is we're saying first console.log the tag, but then edit it based on the ID. So each tag has its ID, and then we're finding the tag IDs and adding that based off of that. So tag data, here we have that dynamically set up. So if I go to this one, this is the reading room inspiration. So we have reading room inspiration, we have the anchor position, and then we have the stem vector. I'm just using one unit in the vertical axis as the stem vector. And then we are embedding a video in it. So the media type will be matter tag.media.video because that's specifically mentioned in here. So you have to specify the type. So you could have photo or you could have a video. One drawback at the moment is that the web component, since the Matterport web component that we have set up, because it's in beta version, it does not allow custom HTML embedding into this. So we cannot have like a customized HTML that shows up. So what I mean by that is like right now, this has a particular format, right, that we have to follow. And then the format is based off of how the creating matter tag is shown. So this is the typical format that we have. But if you want to create some kind of an customized HTML on top of it, to have your own CSS and own styling in the matter tag, the web component specifically does not allow you to access the matter tag in that fashion. I'm hoping in the future they might allow us to, so that we can really customize how that panel in the Matterport looks like, to have, so you can have like PDFs, you can have like a image slider that goes from one slider to the next. You could have maybe buttons embedded into it in some way. So, but that's for the future when they allow us to do that. But right now it's not possible. So, moving back to this. So we're adding this information. So we can get into how are we creating that information. So for that, we need to first get the anchor position, like where do we want to place the matter tag? And so for that, we need the right click handler, which is set up, that gives us any particular location in space that we want. So I can just keep clicking and it gives me where we want to place that, right? And so this is pure JavaScript. This is JavaScript that is working with the SDK to give us the 3D coordinate system. So to do that, we are going into the function which says, I just need to find it. Yep, mouse click handler. So we're adding a mouse click handler, which then at the instance of when we're adding the mouse click handler, it runs a MP-SDK pointer intersection. And why that's important is because you'll notice that when I'm on the ground, it's a horizontal disk or sweep, and then here it turns to vertical. And so what the SDK is allowing us to do is to understand this transition within the Matterport scan, and that's where the intersection happens. So what it's doing is that it's telling the mouse handler to intersect with the SDK 3D point cloud data information, saying when my mouse intersects with the point cloud, tell me if I'm horizontal, if I'm vertical, or if I am in the other way around. So it gives you all three specifically here. And so that reference documentation can be found in, so instead of tag, we go to pointer. Yep, there. So we go to pointer, and then in that, we're specifically going to the intersection. There's not many commands, but the only property for this is intersection, which says intersection of data object that can be subscribed to. So subscribing is the language that Matterport uses, which says to embed or getting the information out of the Matterport scan that we have. So when we say subscribe to sweep, we're saying use the sweep information that's in the 3D scan, and or when we're saying subscribe to the location, it's like use the information location that the scan is giving us. That's the vocabulary they use when they mean subscribe, which is like you're subscribing to the information that the Matterport 3D space offers you. Right? And then so we're saying add just basically on event, add event listener on mouse down, just console.log the intersection position that we have. So in that, we will get that information out. We're using a spread operator because if I don't, then you'll notice that let me just log this, so you'll understand how the actual console.log for the position happens.
Mm-hmm.
So
Okay. It's an object.
it's an object, yes. I'm not entirely sure why it's in this format, but and one thing that I noticed is there is a slight discrepancy. So if you see negative 5.33, but then it says negative 5.52, I was not entirely, there's no documentation on why this discrepancy is, but when it comes to accuracy level, it's best to just use the first one that we have. Yeah. I don't know why it doesn't make sense directly to have this as two different objects. But anyways, so yeah, because of that, we're just getting the restructuring the object itself. Yeah. So what's good is these matter tags can be placed on top of objects as well. So you'll notice that if I go to this table, the matter tag is not just bound to the floors and walls, but also the object that we have in space. So I'm going to add a tag here specifically. So I'm just going to go right click, and it gives me the 17.93. So if I go back to tag.data, I will just copy this, paste that, and I'm going to say desk as my label. And so my anchor position will be this 17.93. Again, it's up to you how much of how many decimal points you need to use. Up to 2 is fine. Make sure you get the negative in there, because I mean there are chances you would miss that negative, and then the tags comes at a different location. And then I'm just going to keep the description and media type the same for simplicity. And then the stem vector, I could make this horizontal instead of vertical. So in that case, so this one which is copied, you will notice that this one is horizontal in space, and that's why we have the x to be 0.5, because in the coordinate place, right side out is x. So if I go to plan again, if I see this, for my matter tag to go rightwards in a certain distance, I'm going x in a positive direction from here. So in my case, I want to do negative y so that I have a tag coming out this way, out, downward. So I'm going to use my x to be 0, my y to be negative 0.5, and my z can remain 0. And in this case, maybe I'll make a white tag. So we do that, save, and we'll should see a tag that is pointing downwards with black there. So we have this. But then I can change that to the z-axis so that it's sticking out, and it's down. So I can keep that as negative 0.5, but then also do negative 0.5. and we will have an angled tag. Nope. Did I change that? Oh. Oh, it's inside the space. Okay. Yeah, it's there, but it's inside the space. So in that case, then I should do positive 0.5 so that it's upward facing. There. So in that now I have an angled tag from there in that color that we want specifically. With me so far?
Yeah.
Yeah. Great. The next would be to add the paths and the text. And so for that, I'm just going to go over the object handler that we have set up because that's set up for both. And then we'll go over how path and then the text is set up because the path and the text uses two concepts which we have covered. One is to working with the JSON file, and then the second is getting these coordinates on where we want the text to be. And on some level, the third one is what's the rotation for each of these texts that we want to be at, right? And so also one other thing you will notice is that when I hover over the text, my disk or sweep goes away. And that's because this is a Three.js object that is superimposed onto this, we're basically detached from the Matterport SDK at that point. So we don't know, I mean, the mouse handler doesn't understand that you're in that space or you're bound to that space when you're in the Three.js object. Because this Three.js object is a superimposed on top of the scan. And a good way to demonstrate that is if I go to my level 3, you will still see the Three.js object in the plan. If I go to a lower level, you will still see it because in the 3D space, there is an instance of the 3D object getting rendered. But when I go to my 3D, you will see that it is on that space. What that means is if I'm in the space, the space below in plan, I will like right below this. I think it's taking me to, yeah. So I'm in the lobby below my lobby above it. I will not see the 3D object.
Mm-hmm.
But if I go to my floor right above it, I will see it. And that's because the 3D object that we're creating is part of the overall scene and not bound to the scan that we have. Does that make sense? Like,
So you had to give it a certain elevation when you were creating the path. So that's why it knows that it only appears at that height, not below.
we're not really giving an elevation per se. Like, we're getting the elevation from the coordinate point that
Yeah,
we have. So when I
yeah,
right
yeah,
click on it, yeah, we're
yeah,
getting that it's at 7.15. It's just that the Matterport SDK is allowing us to fetch this information from the scan.
yeah, of
But
course.
we're not binding the scan and the 3D object. We're placing the 3D object in the the scene that we have. And that's why this documentation is important, because this documentation tells you that we are making amends to the scene. We're not making amends to the scan.
Makes sense.
Whereas in the fly-through and the tag, we were directly impacting the scan and not the scene. That's a big difference. And that's because if I go to my plan view and if I go to a different level, my tags go away because they're part of the scan that is above me. They're not part of the scene that's around me. But my 3JS object is part of the scene that's around me and not the scan that's around me. Yeah?
Interesting.
Yeah. And so if we are uploading an FBX or an OBJ object, then that would be bound to the scene. So that would be bound to the scan, not the scene. So in that case, we don't need to do this specifically. So there is a documentation of that here. Under tutorials, working with models, or no, working with FBX. So there is an FBX loader which allows you to load an FBX over here. So you could have something like this. If you have a 3D mesh, you could embed that directly in the space. Yeah. So I'll just go over the object handler the way we have set it up. So step one, we're getting the Matterport SDK, and then we're registering a path, the path that we get from here. So there's a path, and this path factory, text factory, this is all part of the reference documentation. Like the use of these variables is from the documentation itself. Is defining a path factory, defining a text factory, or like object factory is what they call it. So we're registering the path to the SDK, and that allows us to render it. But then we're also creating. Let me put this. One sec. Let me put this on the side. I just want to make sure we have that documentation on the side. One sec. Let's use. Let me put this on the side so you can just look at these together on how it's working, right? So we're creating the I component, which is this. We're creating an instance of that, an abstract instance of the I component, which is the add object. And then the I component then creates a self-sustaining node. So we're creating a node between the I component and the node object. So we're creating a new node object, which is this I node over here, allowing an abstract class that would allow us to create the I node. And then we're creating the component itself within that. So we're going from object to node to component in this abstract object that we're creating. We will then use this add object to register the path in it. So we're doing add object and then component name, which is the path that we have. And then the parameters that we give it are these path points, dashed, and color, because we have set these up in the as variables that we will be using in the path itself. Same thing with the add text. We're doing a text component. We just add object and then passing the text and then the components, the arguments that are bound to that text object. And then to allow the hover, and then to allow the hover and then the click, we're setting up two classes, and these are JavaScript native classes, which is the click spy and then the hover spy that would allow you to enable click and hover in the JS environment, right? And so then when we go back to the index to add the path, we will say add path, and then for each we will just create a 3-vector object specifically to that in that location. So you will notice one thing is that in this, we are not really using the Matterport SDK specifically to add the object. We're just using the Matterport SDK to get information that will allow us to create the object in the scene.
Yeah.
So you could essentially create an object out in space also, if you would like to. But in that case, then you wouldn't. We can just get that coordinate there and just add something that is outside over here. Yeah. And then just a more abstract function to add text, like fitness room, cafe room, lobby room that we have, the 3 spaces that we have added. Oops, 3 spaces that we have added to this. Yeah. And then the way the JSON file is set up is that if I go to paths data, I'm just providing the anchor position for each of them. And again, this is the horizontal, these are the coordinates that we get from the SDK. So my first path is this one, the red one. And so to get that, I'm just basically going from one end, which is right click, and get the 3.8, 83-ish, 7.15, 16.5. So I'm just inputting where do I want the tag to be in each of them. And then dynamically setting the color and if the dash needs to be true or false, which is set up in the path component. So if I go to the path component, I don't want to get into too much detail about the 3JS part of it, but just a quick overview on 3JS is that so 3JS is a library in JavaScript that allows you to embed 3D objects onto your web applications. It's well documented. There's a lot of examples that people use to add 3D objects to any of your web apps. And if you go to documentation, it's really well documented on how you want to set up different 3D objects. And I think if I go to, there are also examples that would allow you to look at some of these. So if I go to examples, you will see here's a man's like this is completely on the web. It's rendered on the web browser that would allow you to make changes dynamically to the person, and you could create full scenes like these in the space. And I'm moving around with my mouse, so it also interacts with the mouse handler that we have in this. So just to quickly go over this in terms of documentation, if I go to 3JS documentation, I'm just creating a native buffer geometry in this path. So the path component is where I can set up all of my 3JS logic. So if I wish to add a bunch of cubes, if I wish to add some spheres, if I wish to add anything else specifically, you would use a path component to do that specifically. But then you will notice at the end, we're just using the path factory and returns new path. So then if you create a new one that says, I don't know, instead of path, we can have text or line. So if you say line component, you would just use this template, and instead of doing path factory, you could do line factory, returns new line, and then go back to object handler and say MPSDK scene register line as line factory, and just import line from there. And so with that, then you can create another object in your scene specifically to get that. So moving back to this, I'm just creating a 3 buffer geometry. So if I just search buffer geometry, it will give me a quick overview, representation of a mesh line or point geometry. It's just I can add a line essentially using 3JS. So 3 buffer geometry over here. and then adding a line material, which gives me the material, line weight, whether it's a dashed or not dashed. And you'll see that in spaces where we want to create that dynamically, we're just using this dot inputs, where we're dynamically placing the inputs from the tag paths data. So color, dashed, and path are three dynamically placed inputs in the path. So we have path points, dashed, and color. We're setting up defaults, but then the color will be this dot color, this dot inputs, and then the path. I'll just go back to this quickly, because if I go to component, IScene component, they offer a really easy to use template. So you're saying box, and then we're saying on init. So this dot init, define the function. There's a 3, this dot context dot 3. So we're basically using that and setting up material, setting up geometry, setting up mesh, and then on event destroy. And then at the end, you'll see box factory, return new box. That's what we're doing here, except we're doing path factory, return no path. So this is the base template that you would use to set up any Three.js object that you want in the space. And then in the object handler, we are using the node. The node doesn't really do much. It's just a connection point between the object that you have and then the root that you have where that is added to the scene specifically. So it's handling the life cycle in terms of when it's like it's saying when the scene runs, generate the object. When the scene collapses, kill the object. Like that's what the node is doing. And then in the I component itself is where we're setting up the click spy, like the spy on events that we can have specifically to that object. So what that means is we're saying that for any object that we have, give it a click spy, give it a hover spy as classes, abstract classes, so that we can add click and hover functionality to it. But we're adding click and hover functionality only to the text that's on the floor and not to the path. Also, you'll notice that when I'm in the space, you will notice that we have this flicker, and that's because it's part of the scene and not part of the scan. And so the Matterport camera doesn't really know how to render this. It's the scene camera that's trying to render the path. So when you're at 0.90 degrees to it, you'll notice that sometimes the path just disappears to it. Yeah. Because you have the Matterport scene camera, and then you have the Matterport scan camera superimposed on top of each other. But now the Matterport scene camera has an object that it wants to render, and then the Matterport scan camera has its own 3D space to render, and that's why you would see this flickering happen between the two. Yeah. So to change the path, I mean, you can just to change the text that we have or the path that we have, we can just change any of these inputs specifically. So if I change this to FF, okay, this is the hex color. So if you want to do, we can do RGB to hex. There's a converter. So if you want, we can just go to RGB to hex. So I can just show that quickly. So I have this. If there's just a I mean, really, if you just go to RGB to hex conversion, just type the 3 RGB values and then ask, it'll give you that. But say if I want 255, so like pure red, it's going to give me FF0000. So that's what I'm using. So Matterport or 3JS, I would say per se, requires an hex input, so we can use that. So in my case, I want black or white. If I want white, then it would give me all Fs. So I can use that. Here's I can change this value. I think it needs lower cases, and then I can change the dash to false. And potentially we can also change the paths. Instead of going back to the lobby, I could have it go straight. So the way to do that is I go to this corner or this location. It says 17.72, so I'm at 17.72. But then the next one, or the last one is at the lobby. But instead of that, I just want it to go here. So I will get that. So 25.57. We can keep the Y the same. And then the X will be 16.33. So now when I save it, we'll change the path specifically to go to that point. Oh, okay, I think I missed this one. So I guess we can remove this one. We don't need the one in the middle, but then just have this one. So I would just go straight to that path. Yeah. So essentially what you could do is instead of a path, you could also have an image. So you could have a typical floor plan drawing that's superimposed on top of this so that you see it only in plan view, but then in the dollhouse or the immersive view, you don't see the floor plan in it. There's a lot of applications. As long as you can bind 3JS to Matterport, you can do literally anything 3JS can do on a web browser. So just expands the capabilities of 3JS in a Matterport space. Any questions?
No, I don't have any questions at this point. One question that I had earlier was what's the cost like for one scan of a building? Do you have any idea, like ballpark numbers?
So the scan itself is free. Like
Oh yeah,
yeah, so anyone can. So you would purchase the camera once, and then you can just go and scan the space. So you would just be billing to the person who is charging it, who's scanning it. So there's no scan, but when you have to stitch the scan, that's where that's where Matterport makes its money in the stitching process. So that can be. I mean, we've had anything as low as 1,000 to anything as high as 20,000 based on how many scans you wish to do, uh, how many points you have in space that needs to be scanned typically. So for something like this, like if we consider this as a example of the space we're working with, I can see this going maybe 4,000, 3,000 ish, yeah, to do the whole scan, to do the whole stitch.
So
Maybe.
So, and how much time will they take, like roughly to stitch the scan? And then later on, once you get the scan, in terms of putting up these tags and paths and whatever, what would be like a ballpark time that goes into one assignment like this?
So the scan stitching is from Matterport's end. So that, I mean, they take something like even 3 or 4 days. Like within a week, we've had them scan.
Okay.
It's just how many what's their backlog in scanning at that moment when you ask for the service. So within a week, typically, they would scan and give it to you. They're also really good at working with you on QCing the stitch, because sometimes what happens is in these places where you have, two different floors. So this may not be a good example, but if you have scanned, say, a stairway that's connecting two floors, at that point you have two different scans uh, that needs to be connected through that stairway that that connects the two floors. So in that case, they will work with you to QC on how you think the stitch was. We've had times when we were not completely happy with how the stitch was, or the stitch was broken, so they will go back and fix that for you. So they're pretty proactive in getting that to you. And then the development process, I mean, if you want to do something purely native in just the scene, probably not as much time. But if you want to add like if you want to create additional functionality to it, like we saw that project where you have like a fully well-built web application, then yeah, it would take you more time to do
Yeah.
that. Yeah, yeah, that's on how many features and functions you would like to add to it. Yeah.
And how do you serve this to a client? Do you deploy them somewhere and then give them a link, or how does
Yes.
that work? Yeah.
Yes.
So
So the
that's
scan itself, so like if you have if I let me go to I don't really have a scan in this where's do I have that open? Yeah. I mean, I don't really have any scan in this space specifically, but if you have a sample space that you have, this is just, I think all of you would be getting this. You could I don't think there's a share option for the sample space itself, but you would see that if you have a scan, you can share that. An option shows up saying share, and you would be just able to, okay, share and invite. Yeah, so this one's limited because this is just a free version, but Matterport, let me pull that if I have. So if you just have a raw scan that you would like to share with your client, you can just do that through the app itself, that this account itself. So there's an article. Okay, this one. So there is an article specifically that goes through this. So you can share privately, you can share with a password, or you can just keep it unlisted if you would like to. So they provide you different options of sharing the scan, and there's good documentation on how you can do that. But what that will do is that will just give your client access to just the scan, nothing
Yeah.
that you have embedded on
Not
top of
not
it.
the app, yeah.
Yeah, but then if you would like to show this, then you would have to deploy this to a server, uh, internal or external, and then provide that as a link, which we have done in the past. We've done this for clients, or we've used that deployment for just internal sharing in the office that we have.
Yeah.
Okay. Any other questions, high level for this? So there's a few, I mean, I could go into the non-development side of Matterport a little bit, which is Matterport does offer you some features like it has come up with this new thing called furniture. Uh, so if you have a scan, uh, it allows you to remove furniture from that scan by just a click. So it gives you the bare bones uh, of the scan. Yeah, defurnish your space. So they have this thing called defurnish your space, and what that allows you to do is just as what it says, defurnishing the space that you have in your scan. Yeah, so with that, it would just defurnish it, I think. Yeah, there's more than one way to do it. There's some videos online too that explain you how to do it, but it's just really a click of a button that would remove all the furniture and give you the bare bones, which is something useful for architects or interior designers or anyone who's just doing TI scopes specifically, where they just want to see what the space is without any of the furniture. It keeps the casework. So if you have anything that is embedded in the space, so like countertops or anything that cannot be moved, it retains, but anything that can be moved is removed from the space. It also does phase blur, so you could, if you want to, and they have an AI set up so that it just goes through all your space, and if it sees any face, it would just blur the faces. If that's something that is, some clients usually like that, they don't want, or medical staff or any of that, or it allows you to also blur areas in your spaces. So any confidential information can be blurred before you share it with the client or externally. So these features are available on any scan. You don't need any programming knowledge to do these function, to add these features to it. Yeah.
Interesting.
There's also again, you would need a real scan for me to demonstrate this, and unfortunately, I don't have a real scan that I could use for this workshop. But one other thing that Matterport allows you to do is it also allows you to crop certain areas out. Let me see if the gallery scans allows you to do that. Let's go back to maybe they do. I'm not entirely sure. So if I open this scan, it might be, functionality might be present. Does it? I don't think so. Yeah, but there is typically an edit option that allows you to crop spaces within here. Oh, here, yeah. So I guess this has it. So if you are on your default space, if you go to edit, you have these functionalities. So you can add measurements, you can add labels, you can create, you can also trim your spaces out. So there are some basic functionalities that this adds to this here. Yeah, so defurnish. I mean, I don't think this one has any furniture anyways, but you can do that too. So if you go to trim, you can set up a trim, which is this red box. So what that would allow you to do is if I'm in top view, I can move this, say, to this half and then scale it. And then hit OK. So now the space is present. Like I have the scan, just that then if I hit preview, it's like I have the scan, it's just it's cut off. Like I can't get into it. I should just do that in 3D because I think there's some pieces that I missed as a part of that. So you will see, yeah, I think I missed that. But yeah, so you can trim spaces out also in your scan, which is helpful. For confidential spaces that you don't want to share with your client, you can just do that. Or this is helpful when you're doing outdoor scans, or like if you have so you'll notice not in this because this is a cleaned up scan anyways, so it's far better than what you would have. But when you do a typical scan, if your camera is at a point that's you can see outside, in plan view, if I just want to quickly demonstrate that in a dumb manner, what it will do is if you have this, you will see, a bunch of like frays coming out because that's what the camera has captured when it was placed, in that location. Like when the camera was here, when the camera was here, when the camera was here, you would see that it will go beyond the space to capture these things outside. And when you're sharing this with the client, you might want to clean that up. So
Yeah.
you could use this to just create a quick crop. So like, yeah, this is a good example. You see this broken piece?
Mm.
That's typically because it was when the camera was here, it captured some of the outside that came into the space.
Yeah.
So you could trim that piece out and before sharing it. So there are a few options available by default, but we're getting into the SDK aspect of it. Okay. So the last one is just adding text. I mean, this is basically the same as adding the path, except that we're just adding some additional information, which is the sweep ID. And what this sweep ID will do is that when I'm in plan and if I'm in on a text, when I click the text, go to cafe, it brings me to this sweep, which is the 7947, which is the 7947. So I'm seeing uh, in the lobby, in the cafe room, like when I say go to cafe, move me to this sweep. And then when I'm on that sweep, what's my rotation specifically to that sweep? So when I landed in that spot, I was looking dead north, which is the 000, but I could look 90 degrees to the right. And so then when I'm in that spot, it will change me, change my location to that. So we're using the same concepts again, as we did previously. So go to cafe. Now I'm looking at the cafe directly and not this. So adding text is set up in that same way that we have here. So we're saying sweep, move to the floor tag, which we did previously also to set up the fly through. And then we're saying rotation, give me the rotation. And we're passing in the base color and the hover color. So this is just a function that helps set that up, the functionality of that.
Mm-hmm.
And then this text doesn't have to be on the floor. I mean, I'm using this to be on the floor because it's just how it works. But if I want this go to lobby to be at a certain height, I mean, maybe I can try this. I can click on that. It gives me Y 7.88. So I could use that here. Sorry, here, lobby room 7.88 as my Y, and then the text would move up. And then you could rotate the text also and where it wants to be. There, so now we have the floating text. This is a really good, I mean, you could use this for like wayfinding or having people click and then move in any direction. This text can be placed in any way you want. I mean, and then so in that, if I go back to the text component, I'm setting up my mesh rotations in a particular way. But so I'm seeing along the x-axis, it's 45, and then the other two is just 90 degrees. But I could say, and I'm going to test this, I potentially could make this rotate also in that fashion. But again, this is something that you could decouple from your Three.js logic so that it's dynamically fed in. You don't have to change, because what that's going to do is going to change. Yeah, that's what I thought. It's going to dynamically change every path, every text field. So maybe you can do negative. And that's all. But yeah, so it's about how you set up your code. So this is set up as a generic component that's affecting every single text field that I have, but you could have it set up so that, you could have that, right? Any of this. Yeah, go to lobby. Yeah. that essentially covers all the different functionalities that we can do with this, different types of functionalities that we can do um, with it. Hope this opens up new thinking thought processes on how we can use Matterport uh, on projects. I mean, creating showcase projects is really helpful, both from a client onboarding perspective, where if you can show a few of these examples to your client and say, if we scan your space, here's the 10 things we can do with the space, here's the storytelling that we can do with the space, is going to be really helpful for you. You could create so you're not bound to just have one of these scans. You could have like 2 or 3 of these scans in your web page, one below the other, and each of them showing different times in space, different times along the construction, to have a more uh, you know a time-based conversation on the construction. So there's a lot of applications to this, but the foundation to this is embedding the scan on the web browser, getting information from the scan using the Matterport SDK, pushing information back to the scan using the Matterport SDK, and then understanding the conceptual difference between what it means to be in the scene and what it means to be in the scan. Yeah. Any questions? Is there anything you would like me to go over again?
No, I think like when I actually get into this, I might have more questions, but as you
Yeah.
showed, there is great documentation, so
Yeah.
that's the way to go.
Yeah.
But this was a great introduction to this
Mhm.
this workflow that I had no idea of.
Right. I wouldn't say Matterport has the best documentation. I think they're still building it. Like, I mean, 6 to 8 months ago, it wasn't up to this also. Yeah.
I mean, to have documentation is also good documentation, right?
That
Like
is true. That is true. Right. That is true. But yeah.
I mean, it's really interesting to see this. You know, there. I think I spotted a few application examples. You know, that go beyond just the scan, like construction sites, or
Yes.
you know, especially if you can project. You can import FBX, OBJs, so then
Hmm.
you know this. There's a lot there for reconstruction,
Hmm.
basically, not
Hmm.
just you know, just a static model.
Yeah.
Yeah, yeah. I'm wondering how. So you said there are no like, are there any template scans that someone can play around, or did they miss this? Like
No.
sample scans?
Yeah. So this gallery that I shared. So this one. So if you go to Matterport gallery,
Yeah. Mhm.
yeah, this is where you would find that. Um, so this is helpful. Just to go through that. Yeah. And again, I mean, I'm logged in, but you don't even have to. If I sign out
Mhm.
and refresh, I still get access to everything, and that's really helpful. So we can use this specifically. The only drawback, or not drawback, but like the part that is good to know is that if I'm on my account, let's see which tab that is. Oh, so many. But if I'm in my account and if I'm in my signed out, all right. Um, one sec. Or maybe I can. This is good, but if I'm in my account, I can only use the free account to do localhost uh, workflows. So if I go to the SDK,
Yes.
I cannot add another like custom domain that I have that I'm setting up. So for that, you would need to purchase the base plan so that you can host this externally and
Yes, yes.
send it out. Yes, the free plan only allows you to do local host development.
Yes, and that's for an existing scan, right? Or
That is for
with
any
with the
scan.
gallery, with the gallery.
And no,
Or
that is for any scan. So like
okay,
in my account right now, I don't have any scans because this is a free account. But you could go out, make a scan, put it here in your
okay, okay,
account,
okay.
in your
Sure.
account, and then you could use your free developer account to just do development
Yeah,
on
right.
local host. Yeah,
I see.
right. But for testing, this helps.
Yeah.
Yeah. Anything else? Good. Great. Thank you all who joined. Please reach out if you have any questions or also would like to collaborate on doing any of these together. I mean, I'm looking into doing more of building such more examples and showcase product projects at the moment, working with the SDK. So happy to collaborate on this, and hope this was helpful. Yeah.
Definitely helpful, Atharva.
Mhm.
Thanks for presenting.
Yeah.